This lesson is on section 10.6, which is entitled Circles and Arcs. It truly begins our circle unit, which goes from here through chapter 12. Definition of a circle is the set of all coplanar points that are equidistant from the center. That is different from the definition of a sphere, which you will learn in chapter 11. The only difference, however, is the word coplanar. So the word coplanar is very important in this definition, the set of all coplanar points that are equidistant from a center point. When we talk about congruent circles, they are simply circles that have the same length radius. Concentric circles are circles that lie one inside the other on a plane surface. I always think of the Target logo when I think of concentric circles, or a bullseye. An arc is an unbroken part of the circle. For example, if I look at the part of the circle from A to B, that is an arc, or from B to C, or from A to C. Those are all arcs. We measure those in degrees. You can also measure their lengths. Their lengths, however, won't be in degrees. They will be in whatever units the circle is measured in. You need to remember the formula for circumference of a circle, the distance around the circle. Traditionally, that has been taught as circumference equals 2 times pi times radius. More modernly, they have transferred it to pi times diameter, which is exactly the same thing because 2 times the radius is the diameter. But in more modern books, they're writing it as pi times diameter. In the traditional books, you've probably learned it as 2 times pi times radius. You have to remember things like what is the radius, which is halfway across the circle, the diameter, which is all the way across the circle through the center. A central angle would be an angle whose vertex sits at the center of the circle. And the measure of the central angle, in this little picture down here, the measure of the central angle is equal to the measure of the arc. Both are in degrees. The angle is the same degree measure as the arc. We name arcs based on the size of them. If they are a minor arc, in other words, they are less than 180 degrees, and less than half of the circle, we name them by their endpoints. Okay, for example, this would be arc NP. It's less than half the circle, so we just write NP with an arc symbol over the top. A major arc is more than half the circle. We name those by their endpoints and one other point that is on the arc. Order does count. You have to pay attention. A major arc might be from N through Q to P. So we would name it NQP and put the arc symbol over the top. If there's more than one point labeled, you just pick one. Do not name them all. Start with N, pick another point that's on the arc, and then end at P. You could also start at P, pick another point, and end at N. A semicircle is exactly 180. We name those just like we name major arcs. So if it was exactly half the circle, we would start at one, go through another point, and end at the other side. Adjacent arcs, remember the word adjacent means next to. So those are arcs in the same circle that have one common endpoint. So we would say arc PN and arc NQ are adjacent arcs because they share point N. Arc length, which I alluded to earlier, is the actual length of the arc. If I were to lay a string down from N to P and then measure the length of the string, that is the arc length. It's different from the degree measure. And this will be done in inches, meters, whatever the radius is labeled in, that's what the arc length will be labeled in. in order to find the arc length, it is part of the circumference. So you simply take the number of degrees it is divided by 360, because that tells you what percent of the circle the arc is, and then you take that percent times the circumference, which is why you needed to remember that circumference was 2 pi r. All right, so some of the kinds of questions that you're going to get would be the measure of arc NP. When I ask you for the measure, I'm asking you in degrees. So the measure of the length of NP, arc NP is right here. It would have the same measure as its central angle. So since the central angle is 35 degrees, the arc will be 35 degrees. The measure of a major arc, NQP, so that starts at N and goes through Q on its way to P. Well, that would be everything else that's not here. So since this is 35, the rest of this would be 360 minus 35. 360 minus 35 is 325 degrees. To find the circumference of circle M, remember that it's 2 times pi times the radius. Sometimes they will ask you to leave it in exact form, in other words, leave pi in the answer. Sometimes they will ask you to round to the nearest tenth, and then you will actually multiply by your value of pi. So to find the circumference of circle M, it's 2 times the radius. Radius is 8, it was given to us, times pi. 2 times 8 is 16, so 16 pi would be your exact answer. And then 16 times pi gives you 50.3 millimeters. This is your rounded answer. Exact answer would leave pi there. Rounded answer would multiply the pi into the problem. The length of NP, when you're trying to find the actual length of the arc, remember you take your degree measure, how many degrees the arc is, and divide it by 360. That gives you your percent of the circle. And then you take your percent times the circumference around the entire circle, which we figured out was 50.3. So 35 divided by 360 times 50.3 gives us 4.89 millimeters. So that means the distance from N to P, the actual distance, is 4.89 millimeters. That's how you use these problems, or how you use these formulas in section 10.6. Your homework is as follows.